Okay, so regular mold that we would like grow on your fruit, grow on your bread, that is included in kingdom fungi. This is not that. This is something called a cellular slime mold. They kind of look like amoebas because they can move by changing the shape of their cytoplasm. And so this is falls underneath kingdom Protista. Okay, so how cellular slime molds communicate. Two scenarios, when food is plentiful and when food is scarce. Okay, when food is plentiful, slime molds exist separately. They are their own little independent, again, remember what heading this falls under, unicellular communication. So yeast are unicellular, bacteria are unicellular, slime molds are unicellular. So when food is plentiful, they're like, I'm independent. I don't need anybody else. I'll find my own food. I'm good. That's going to change if food becomes scarce. So when food becomes scarce, slime molds start to secrete cyclic AMP into their extracellular fluid, which is just the fluid outside their cell. And that cyclic AMP kind of acts like a distress signal. And so they're sending out this cyclic AMP, and we'll kind of go through the whole pathway in just a second. I even have a video to show you that'll kind of recap that. It's very short. This extra cyclic AMP attracts other slime molds to the area, and they will also release cyclic AMP. So it's a little bit of positive feedback there. So slime mold realizes there's not enough food, food is scarce. Start sending out this cyclic AMP signal, okay? That cyclic AMP is going to attract other slime molds to the area, and they will also start secreting cyclic AMP. So far, so good? And this is the part that makes it really different. Or maybe it's on the next slide. Okay, so we've heard that term, or at least I've mentioned that term chemotaxis to you before. When we learned about phagocytosis, and I showed you that video of like a neutrophil chasing down a bacterium with the funny music playing. Okay, that's chemotaxis. That neutrophil was following a chemical signal that the bacterium was giving off. So the attraction of the slime molds to the cyclic AMP signal is called chemotaxis. Okay, so because slime molds are all being drawn to the same place by the cyclic AMP signal, they actually aggregate, okay? They come together to form a slug-like organism. It's not actually a slug, it just kind of looks like a slug. And the reason that they do that is because these individual unicellular cellular slime molds are so tiny that if they wanted to move to an area where the food supply was better, they can't really cover much ground because they're so teeny tiny. But if they all come together to form this slug-like organism, it can cover more ground in the same amount of time, and you're kind of taking everybody with you to an area where there's a greater food supply. So this is how I think about that. On these cartoons, and I don't even remember which one this is this Voltron? Is this Power Rangers? I don't know. It's one of those. And basically on these kind of cartoons, the little individual parts would come together to form this massive robot-like creature who can obviously walk a little farther, right, in the same amount of time than these individual pieces could. And so that's kind of the way I think about it, is it's kind of like these old cartoons where they would come together and form a large structure that is capable of being able to move, not move faster, but like cover more ground in a shorter amount of time, and get the slime molds, this composite, to where there's a better food supply. So when the slug-like formation finds a more suitable place with a better food supply, they develop into something called a fruiting body, which can release spores. Spores become gametes, and then those can develop into new cellular slime molds, new individual cellular slime molds. And so that's what this is taking you to, okay? And you'll kind of see what that will look like. It actually ends up, you have the slug-like organism, and then it forms a stalk, and at the top of the stalk is the fruiting body that's made up of all these little pieces, and those are your spores. They release spores, spores become gametes, and the gametes, upon fertilization, gametes are just sex cells, will develop into new unicellular slime molds. So this is the reason that slime molds will do this. They don't do this all the time. They only do this when the food supply is scarce. And then I'll show you the video that kind of takes you through this life cycle. And that will be the end of notes for this unit. And then I think we're gonna go next door to the lab. I just wanna organize, because I'm trying to make 2 identical sets of 4 lab stations and give you little directions about what I want you to do with each one. We're gonna use the chalk markers again. We're just gonna do something different than we did the other day, I think. Okay, let's see what this video looks like. I would wait till the video's over, then you can go, because it's too important. Now that's kind of a different kind of slime mold. It's a plasmodial slime. So these are a different kind of slime mold, but I still think it's cool. There's the slug-like organism. So the top is the fruiting body on top. So I just think that's kind of cute.